Chapter 9: Galileo's Struggle. Myths, Realities, and Legacy. The Galileo affair remains one of the most discussed and debated events in the history of science and religion. Often shrouded in myths and misconceptions, it serves as a focal point for understanding the complex relationship between established authority and the pursuit of knowledge. One prevalent myth is that Galileo was tortured by the Inquisition to force his recantation. Historical records, however, indicate that while Galileo was threatened with torture, he was never physically harmed. Instead, he was placed under house arrest, where he spent the remainder of his life. Another misconception is that Galileo's scientific views were universally opposed by the Church. In reality, several high-ranking Church officials and scholars supported his work. The opposition he faced was complex and multifaceted, involving theological, political, and personal dimensions. A further myth is that Galileo conclusively proved the heliocentric model during his lifetime. While he provided significant evidence supporting the heliocentric model, full acceptance required further advancements in science and the work of later scientists like Johannes Kepler and Isaac Newton. The idea that the Catholic Church uniformly condemned all scientific advancement is also a misconception. Throughout history, the Church has been a patron of scientific research, and many clerics have made significant contributions to various fields of science. The Church's relationship with science is complex and cannot be reduced to simple opposition. Galileo's trial and subsequent house arrest by the Roman Catholic Inquisition in 1633 are often oversimplified in popular narratives. The reality of these events is more nuanced, reflecting the complex interplay between science, religion, and politics during the 17th century. Galileo's trial did not involve physical torture, often associated with the Inquisition's darker reputation. While the threat of torture was present, a common judicial practice to emphasize the seriousness of the proceedings, Galileo was not subjected to physical harm. Instead, his sentence was house arrest, a relatively mild punishment compared to what others faced during that period. During his house arrest, Galileo was initially confined to the residence of the Tuscan ambassador in Rome. He was later allowed to move to his villa in Arcetri, near Florence, where he remained until his death in 1642. Despite the restrictions, Galileo was treated with a certain degree of respect, and his living conditions were comfortable, though he was under constant surveillance. The Church's opposition to Galileo was not a straightforward rejection of science, but rather a complex stance influenced by various factors. At the time, the heliocentric model proposed by Copernicus and supported by Galileo lacked conclusive empirical evidence. This uncertainty allowed the Church to maintain its commitment to the geocentric model, which was deeply rooted in both Aristotelian philosophy and scriptural interpretation. The Catholic Church was also navigating a period of significant external and internal pressures. The Protestant Reformation had already caused substantial fractures within Christendom, and the Catholic Church was determined to maintain its doctrinal authority. Accepting the heliocentric model would not only challenge long-standing theological views, but also undermine the Church's perceived infallibility at a time when it could ill afford further destabilization. Galileo's personality and actions played a crucial role in the unfolding of events. Known for his assertive and sometimes confrontational demeanor, Galileo did not shy away from challenging his opponents, including high-ranking Church officials. His work Dialogue Concerning the Two Chief World Systems, which presented a defense of heliocentrism, was written in a way that ridiculed the supporters of the geocentric model, particularly through the character Simplicio, who was perceived as a simpleton. This satirical approach, coupled with Galileo's decision to present his arguments in Italian rather than Latin, made his ideas more accessible to a broader audience, but also more provocative. The Church, particularly Pope Urban VIII, who initially supported Galileo, found themselves in a difficult position as Galileo's perceived disrespect, and the political implications of his work became more apparent. Galileo's trial and house arrest were, therefore, the result of a combination of his groundbreaking scientific ideas, the political and religious context of the time, and his own unyielding character. While the Church's actions were certainly aimed at preserving its authority, they were also influenced by the broader dynamics of 17th century Europe, which required a careful balancing act between tradition and emerging new worldviews. Galileo Galilei is celebrated as one of the pioneers of modern science, and for good reason. His contributions laid foundational stones in various fields, most notably in astronomy, physics, and the scientific method itself. In astronomy, Galileo's improvements to the telescope allowed him to make unprecedented observations. His discovery of the 4 largest moons of Jupiter provided concrete evidence that not all celestial bodies orbited the Earth, challenging the geocentric model. Observing the phases of Venus supported the heliocentric model proposed by Copernicus, showing that Venus orbited the Sun, not the Earth. Galileo's studies of sunspots and the rough mountainous surface of the Moon contradicted the Aristotelian belief in the perfection of celestial bodies, further challenging existing paradigms. In physics, Galileo's concept that a body in motion remains in motion unless acted upon by an external force was revolutionary. This idea laid the groundwork for Newton's first law of motion. Through his famous experiments, such as those reportedly conducted from the Leaning Tower of Pisa, Galileo demonstrated that objects fall at the same rate regardless of their mass, countering Aristotle's theories. Galileo emphasized observation and experimentation over philosophical speculation. His method of systematic observation, experimentation, and mathematical analysis became the backbone of modern scientific inquiry. While Galileo's contributions were groundbreaking, they were not without their limitations and controversies. His work often faced significant opposition, not just from the Church, but also from his contemporaries in the scientific community. At the time, Galileo's telescopic observations did not provide conclusive proof of the heliocentric model. While they strongly supported it, alternative explanations, such as the Tychonic system, were still viable. Some of Galileo's theories, like his explanation for the tides, were incorrect. He attributed the tides to the Earth's rotation and revolution around the Sun, a hypothesis that lacked the comprehensive understanding of gravitational forces provided later by Newton. Galileo had contentious relationships with other scientists, such as Christoph Scheiner, over the discovery and interpretation of sunspots. These rivalries sometimes overshadowed collaborative progress. His abrasive and often sarcastic style in debates and publications alienated many of his peers. His dialogue concerning the two chief world systems, not only mocked the Aristotelian viewpoint, but also personally offended Pope Urban VIII, contributing to his eventual trial. The 17th century lacked the structured scientific institutions we have today. Galileo's ideas had to navigate a landscape dominated by philosophical and theological frameworks that were resistant to change. The political and religious climate of the time severely restricted the dissemination and discussion of new ideas. The Inquisition's actions against Galileo, including his house arrest, curtailed his ability to freely engage with the scientific community. Despite these challenges, Galileo's work had a profound and lasting impact on the development of science. His emphasis on empirical evidence and the scientific method influenced future generations of scientists, including Isaac Newton, who would build upon and refine Galileo's theories. Newton's laws of motion and universal gravitation were direct extensions of Galileo's initial insights into inertia and motion. Galileo's work provided the empirical foundation upon which Newton constructed his comprehensive physical theories. Galileo's insistence on observation and experimentation over dogma and speculation was a critical influence on Enlightenment thinkers and the broader scientific revolution. His legacy encouraged a shift towards evidence-based reasoning that permeated various scientific disciplines. The methodologies Galileo developed for investigating natural phenomena, careful observation, controlled experiments, and mathematical analysis remain central to scientific practice today. His approach laid the groundwork for the rigorous standards of evidence and reproducibility that define modern science. Galileo's ability to persist in his scientific endeavors despite significant opposition highlights the enduring power of intellectual curiosity and the relentless pursuit of truth. His work not only advanced our understanding of the natural world, but also transformed the very methods by which we seek knowledge. Galileo's house arrest, imposed by the Roman Catholic Church after his trial in 1633, marked a significant turning point in his life. Confined to his villa in Arcetri near Florence, Galileo faced severe restrictions on his movements and communications. However, this period of enforced isolation did not stifle his intellectual pursuits. Rather, it redirected his focus towards theoretical work and refinement of his scientific methods. With limited access to observational tools and collaborative discussions, Galileo turned increasingly to mathematics to validate his theories. This period saw a deepening of his engagement with mathematical principles, which became crucial for his later works. The constraints of house arrest necessitated a more rigorous and systematic approach to his research. Galileo honed the scientific method, emphasizing controlled experiments and reproducible results, which became the cornerstone of modern scientific inquiry. Despite his confinement, Galileo managed to complete and publish discourses and mathematical demonstrations relating to two new sciences in 1638. This work laid the groundwork for classical mechanics and addressed topics such as the strength of materials and the motion of objects. It represented a synthesis of his life's work and continued to influence the scientific community long after his death. Galileo's house arrest did not prevent the dissemination of his ideas. Through clandestine means and the support of his followers, his work continued to reach the broader scientific community, fueling further advancements. Galileo maintained an extensive correspondence with other scientists, including his former students and allies, who visited him at his villa. This network allowed him to share his findings and receive feedback, ensuring that his ideas continued to evolve. Manuscripts of Galileo's works were often smuggled out of Italy and circulated among European intellectuals. His Two New Sciences, for instance, was published in the Netherlands, beyond the reach of the Inquisition's censorship, allowing his groundbreaking ideas to gain international recognition. Galileo's students, such as Evangelista Torricelli, who invented the barometer, and Vincenzo Viviani, who later wrote a biography of Galileo, carried forward his legacy. They disseminated his methods and findings, ensuring that his scientific principles endured. Galileo's empirical approach and emphasis on the scientific method inspired a new generation of scientists. His work laid the foundations for the scientific revolution, influencing figures such as Isaac Newton and shaping the trajectory of modern science. Despite these challenges, Galileo's work had a profound and lasting impact on the development of science. His emphasis on empirical evidence and the scientific method influenced future generations of scientists, including Isaac Newton, who would build upon and refine Galileo's theories. Newton's laws of motion and universal gravitation were direct extensions of Galileo's initial insights into inertia and motion. Galileo's work provided the empirical foundation upon which Newton constructed his comprehensive physical theories. Galileo's insistence on observation and experimentation over dogma and speculation was a critical influence on Enlightenment thinkers and the broader scientific revolution. His legacy encouraged a shift towards evidence-based reasoning that permeated various scientific disciplines. The methodologies Galileo developed for investigating natural phenomena, careful observation, controlled experiments, and mathematical analysis remain central to scientific practice today. His approach laid the groundwork for the rigorous standards of evidence and reproducibility that define modern science. Galileo's ability to persist in his scientific endeavors despite significant opposition highlights the enduring power of intellectual curiosity and the relentless pursuit of truth. His work not only advanced our understanding of the natural world, but also transformed the very methods by which we seek knowledge. The Roman Catholic Church's condemnation of Galileo Galilei in 1633 was a momentous event that symbolized the clash between science and religious authority. Over the centuries, however, the Church has undergone significant changes in its approach to science and its stance on Galileo's work. This segment explores the Church's modern reflections on the Galileo affair and its efforts to rehabilitate his legacy. In the centuries following Galileo's trial, historians and theologians within the Church began to reassess the circumstances and motivations behind the condemnation. The growing recognition of the importance of empirical science and the contributions of Galileo to modern astronomy led to a more nuanced understanding of the events. The Enlightenment, with its emphasis on reason and scientific inquiry, influenced the Church's intellectual landscape. This period saw the gradual acceptance of scientific principles that were once controversial, paving the way for a re-evaluation of Galileo's work and the Church's stance. As early as the late 19th and early 20th centuries, popes began to acknowledge the value of scientific inquiry. Pope Leo XIII emphasized the harmony between science and faith, while Pope Pius XII recognized Galileo's contributions to science and the need for the Church to embrace scientific progress. In 1992, Pope John Paul II formally addressed the Galileo affair, expressing regret for how the Church handled the situation. He acknowledged the errors made by the ecclesiastical authorities in condemning Galileo and emphasized the need for dialogue between science and faith. This apology was a significant step towards rehabilitating Galileo's legacy and mending the historical rift between science and the Church. The rehabilitation of Galileo is part of a broader trend within the Catholic Church towards a more harmonious relationship with science. This shift reflects an understanding that faith and reason are not mutually exclusive, but can complement each other in the pursuit of truth. The establishment and ongoing support of the Vatican Observatory, one of the oldest astronomical research institutions in the world, exemplifies the Church's commitment to scientific inquiry. The observatory conducts cutting-edge research in astronomy and astrophysics, demonstrating the Church's recognition of the importance of science. The Vatican's engagement with the scientific community includes participation in international scientific conferences and collaborations with leading research institutions. These efforts highlight the Church's commitment to fostering a dialogue between science and faith. The Church supports educational programs that integrate science and theology, encouraging a holistic understanding of the natural world and the divine. These initiatives aim to bridge the gap between scientific and religious communities and promote a more integrated worldview. The Church actively engages in public outreach through lectures, publications, and media programs that explore the relationship between science and faith. By promoting a dialogue on these issues, the Church seeks to dispel misconceptions and foster mutual understanding. The Church's modern reflections on the Galileo affair and its efforts to rehabilitate his legacy underscore the enduring impact of Galileo's work and the importance of intellectual freedom. These reflections also highlight the evolving nature of the Church's relationship with science, demonstrating a commitment to learning from past mistakes and embracing scientific progress. Galileo's trial and condemnation have come to symbolize the struggle for intellectual freedom and the right to pursue scientific inquiry without fear of persecution. His legacy serves as a reminder of the importance of challenging established authority and seeking truth through empirical evidence. Galileo's resilience and dedication to science continue to inspire future generations of scientists and thinkers. His story underscores the value of perseverance and the impact that one individual can have on the advancement of knowledge. The Church's acknowledgement of its errors in the Galileo affair serves as a lesson in humility and the importance of being open to new ideas and evidence. It highlights the need for institutions to adapt and evolve in response to changing knowledge and understanding. The ongoing dialogue between the Church and the scientific community reflects a commitment to mutual respect and cooperation. By fostering an environment where science and faith can coexist, the Church aims to contribute to the betterment of society and the pursuit of truth. Galileo Galilei's contributions to science and his conflict with the Roman Catholic Church have left an indelible mark on both scientific and cultural landscapes. This segment explores how Galileo's work and legacy continue to shape modern science, influence cultural narratives, and inspire contemporary thought. Galileo's insistence on empirical evidence and experimentation laid the groundwork for the scientific method that is the cornerstone of modern science. His approach emphasized observation, experimentation, and mathematical analysis as the means to understand natural phenomena. Galileo's studies on motion and inertia were pivotal in the development of classical mechanics. His work paved the way for Isaac Newton's laws of motion and the broader field of physics, establishing foundational principles that continue to underpin scientific research. Galileo's advocacy for the heliocentric model and his subsequent conflict with the Church were key events in the scientific revolution. His willingness to challenge established doctrines and pursue truth through scientific inquiry inspired other scientists to explore and question the natural world. Galileo's work influenced Enlightenment thinkers who championed reason, science, and intellectual freedom. Philosophers like Voltaire and Immanuel Kant drew inspiration from Galileo's courage and commitment to knowledge, further advancing the cause of scientific and philosophical inquiry. Galileo's life and struggles have been depicted in numerous works of literature, art, and theatre. Plays like Bertolt Brecht's Life of Galileo and novels like Dava Sobel's Galileo's Daughter explore his story, highlighting the human aspects of his scientific endeavors and his conflict with the Church. Galileo's story has also been adapted into films and television series, bringing his legacy to a broader audience. These portrayals often emphasize his role as a martyr for science and a symbol of the enduring struggle for intellectual freedom. Galileo's determination to pursue scientific truth despite opposition has made him a symbol of intellectual courage. He inspires scientists and innovators to challenge conventional wisdom, push boundaries, and explore new frontiers in their respective fields. Galileo's story underscores the importance of academic freedom and the right to explore and discuss controversial ideas. His legacy is often invoked in debates about censorship, freedom of speech, and the autonomy of scientific research. Galileo's contributions to science are a staple in educational curricula around the world. His life and work are taught in history, science, and philosophy classes, providing students with a comprehensive understanding of the scientific revolution and the development of modern science. Institutions like the Galileo Museum in Florence and the Vatican Observatory engage in public outreach to educate people about Galileo's legacy. Exhibitions, lectures, and interactive displays help convey the significance of his work and its impact on contemporary science and culture. Galileo's pioneering use of the telescope revolutionized astronomy, and his legacy continues to influence modern space exploration. Telescopes and space missions named in his honor, such as the Galileo spacecraft that studied Jupiter, reflect his enduring impact on the field. Modern astronomers build on Galileo's legacy as they search for exoplanets and study the conditions for life beyond Earth. His methods of observation and analysis remain fundamental to the exploration of our universe. Galileo's work on motion and mechanics laid the foundation for classical physics. His principles of inertia and motion are integral to engineering, technology, and various scientific disciplines. Innovations in engineering and technology often draw inspiration from Galileo's approach to problem-solving and empirical research. His legacy underscores the importance of precision, experimentation, and rigorous analysis in technological advancements. Galileo's story highlights the ethical dilemmas that arise in the pursuit of scientific knowledge. Contemporary debates on issues like genetic engineering, artificial intelligence, and climate change often invoke Galileo's legacy as a reminder of the need to balance scientific progress with ethical responsibility. Galileo's conflict with the Church raises questions about the role of scientists in society and their responsibility to communicate their findings truthfully and ethically. His legacy encourages scientists to engage with the public and policymakers to ensure that scientific advancements benefit humanity. Galileo's challenge to the Church's authority symbolizes the broader philosophical struggle to question established beliefs and seek truth through reason and evidence. His legacy is a testament to the importance of skepticism and critical thinking in the pursuit of knowledge. Galileo's work demonstrates the interconnectedness of science and philosophy. His contributions to natural philosophy laid the groundwork for modern scientific thought, emphasizing the need for a holistic approach to understanding the natural world. Galileo Galilei's legacy is a multifaceted one that transcends the boundaries of science, culture, and philosophy. His contributions to the scientific method, his role in the scientific revolution, and his enduring influence on modern science and culture underscore the profound impact he has had on our understanding of the natural world. Galileo's story is a testament to the power of intellectual courage, the importance of empirical evidence, and the enduring quest for truth. As we reflect on Galileo's legacy, we are reminded of the ongoing struggle for intellectual freedom and the need to balance scientific inquiry with ethical considerations. His life and work continue to inspire scientists, thinkers, and innovators, encouraging us to push the boundaries of knowledge and explore the mysteries of the universe. Today, as humanity confronts the frontiers of knowledge in areas such as artificial intelligence, quantum physics, and genetic engineering, the integration of philosophical and potentially spiritual perspectives is crucial. The pursuit of truth demands that we address not only scientific questions, but also ethical and philosophical challenges. By fostering a new generation of thinkers educated in a balanced approach that includes scientific, philosophical, and spiritual wisdom, we can better navigate the complexities of the modern world. The quest for knowledge is not just about discovering new facts, but about understanding the deeper implications of these discoveries for humanity. As we move forward, let us draw inspiration from Galileo's journey and embrace a holistic approach to inquiry that respects the contributions of science, philosophy, and spirituality. In doing so, we can continue to pursue truth and contribute to the betterment of humanity.